In example 20, we are given a curve of the function of x. And within the curve, we have specific points, like we have point A, 2, -1, and we have point B, 6, 4. Those points are very critical in transforming our curve. And we are told that sketch the graph of part A, 2 fx -1. Or rather, we are supposed to sketch the graph of y is equals to 2 fx minus 1. Before we do anything, we must examine our new function, and we can already see that there is a factor that is multiplying the function of x first, after which we are subtracting 1. So there is this transformation and there is this transformation. There are two transformations. So which one do we start with? Of course, we start with the multiplication one. And we can already say we must talk about the original function of x, which has first of all been multiplied by 2, and you can see multiplication outside. You can see the 2 is outside the x, it's outside the bracket. Go to the Mayo and you talk about multiplication outside is a vertical stretch of scale factor a. So y is equals to 2fx is equals to, before we go to -1, is equals to the vertical stretch of the original function fx by scale factor 2. What does this mean? The vertical means we are affecting only the y values. We are going to concentrate on the vertical movement. We are only going, y values change and x values do not change under vertical stretch. Stretch means what? We multiply by scale factor 2. Meaning that if we were now to construct this kind of graph or sketch, we will bring it over here and have all y values multiplied by 2. And 0 doesn't change, it remains 0. But what about -1? -1 changes to -2. This 0 doesn't change. What about 4? 4 multiplied by 2, it becomes 8. So we're going to have a sketch that looks like this, and we need to now give it new, this is a prime, x doesn't change, 2 minus 2. This one is b prime, x doesn't change, but y changes 6, 8. That is only after the very first effect of transformation. But beyond this, there is y is equals to fx minus 1. Now, we have finished the vertical stretch by scale factor 2. So we are now going to concentrate on this part. And I'm going to introduce now a different color, which will give us the final curve, meaning that the curve which we already have, which is 2fx, which is this one, we now affected by -1. And as you can see, -1 is addition outside. It is outside the bracket. Go back to the Mayo, talk about addition outside, which means addition outside, it's vertical translation of a steps. And what is our a? Our a is -1. That means vertical translation of a step. Meaning that, again, vertical, we will focus on the y-axis only. Vertical translation of y steps, it means all y values subtract 1. So if this was 0y, then it will become minus 1y. If this is minus 2, it's going to become minus 3. If this is 0, if this is 8y, minus 1 is going to be 7. If this is 0, is going to be, so we are going to have a curve that drops down one step, and it is simply going to look like this. So the red one is now, and we can actually give this code, this is -1, this is -1. What are the coordinates of this particular point? Call it A double prime. It is 2 minus 3. What about B double prime? The coordinate 6, 7. And the red one now is the graph of y is equals to fx minus 1. Please remember, we have been assisted in a great way by our table here. That's why I did not wrap it, so that we can actually be consulting it every time we want to translate the original curve. So that means the combined transformation has actually been done on this particular curve, and the red one is our final curve. So please watch out for part B in the next video. For now, this is it. All right.